We're on the third lesson of Chapter 6, which is volume of pyramids and cones. First, we're going to find the volume of pyramids and cones. Then we're going to explore the effects of changing dimensions, and then we'll do a real-world application. Just a reminder that volume is the amount of space an object occupies, and it's measured in cubic units, like literally think of cubes occupying that space to measure it, whether they be inches cubed or centimeters cubed or feet cubed. Pyramids and cones use the same formula to find volume. You do base times height just like those prisms you did last time, but now we multiply that times 1/3 because pyramids don't occupy the same amount of space as prisms do because they all meet at one point here. Same thing with the cones. So that decreases the volume, and that's why we multiply that times 1/3. So let's find the volume of each figure here. We have a triangular pyramid, meaning the base is a triangle. So if we're going to follow the formula, we do the base times the height and then multiply times 1/3. So the base is 4 times 9. So 4 times 9 is 36, but it's a triangular base, so we need to divide that by 2. So the base would be 18 centimeters squared. Then the height of the pyramid is 9. So we would multiply that times 9 centimeters. So 18 times 9 is 162 centimeters cubed. But then we need to multiply that times 1/3, or divide it by 3 if you want to do it that way. So we do 162 divided by 3, that would be 54. So our answer would be 54 centimeters cubed. Let's solve for B then. This is a rectangular pyramid because the base is a rectangle. That makes it a little easier. We don't have to divide by 2. So we do 9 feet times 7 feet, which would be 63 feet squared. And that's times 8 feet, which is the height. 63 times 8 is 504. So 504 feet cubed. But remember, it's 1/3 of the base times the height, so we need to multiply this times 1/3 or divide it by 3, and then it's 168 feet cubed. Let's follow the formula for this one. We have a cone here, so this is the base, this circle here. The circle has a radius of 7 millimeters. So we find the area of this, we do radius squared times pi. So 7 times 7, which is 49, times 3.14, 153.86 millimeters squared, times 8, which is the height, 8 millimeters. So that would give us 1,230.88. That'd be millimeters cubed then. Then we need to divide this by 3 or multiply times 1/3. 410, and we're around to the nearest tenth here, so 410.3. So 410.3 millimeters cubed. So we multiplied the base times the height for all of these and then divided by 3 to give us our volume. Make sure your labels are always in cube for volume. Here we have a cone that has a radius of 3 meters and a height of 10 meters. Explain whether doubling the height would have the same effect on the volume as doubling the radius. So remember, our radius here is 3. Our height is 10. So let's find the volume of this regular cone here. Find the area of the base times the height. So the area of the circular base would be radius squared times pi. So 3 times 3 is 9, so 9 times 3.14 is 28.26 meters squared times 10 meters. And that would give us 282.6. And then the meters cubed. So there's our original volume. So we'll say volume. Now let's find out the changing dimensions. Let's try doubling the height first. So this would be the area of the base times 20 now. So 28.26 times 20 would be 565.2. So we'd say double height, 565.2. So doubling the height does double the volume. Let's check out the radius then. So if the radius becomes 6, we need to change the area of the base. So 6 times 6 is 36 times pi. Let's do that. 36 times 3.14. That'd be 113.04. So 113.04 meters squared times 10 meters, and that would be 1,130.4. That would be meters cubed. So we find that doubling the radius instead of doubling the volume, it quadruples the volume. And just like our last lesson, this happened too. When you double the radius, it actually quadruples it because you're doubling it, then squaring it. So that's why making the radius twice as long would actually quadruple the amount of space that this cone occupies. Let's do a real-world application. It says the Great Pyramid of Giza in Egypt is a square pyramid. Its height is 481 feet, and its base has 756-foot sides. So it says find the volume of the pyramid. So since this is a square, this is 756 feet. This side is 756 feet. So that would be the base. 756 times 756. So the area of the base is 571,536. And that would be square feet. We multiply that times the 481 foot height. So this becomes the amount of cubic feet. But remember, we're not done here yet, because the volume of a pyramid is 1/3 of this total. So we need to divide this by 3. And that gives us 91,636,272. So 91,636,272. And that'd be cubic feet. And that is a lot of cubic feet of material, which is why it's called the Great Pyramid.